Hello everyone, this is Allison Washa, and this is the vlog presentation for the Deliverable 7 assignment. Physics principles and various real-world examples. There are two very good real-world ways that physics relate to business. One way is marketing. There are two physics principles that closely relate to marketing. The first one is Newton's second law and brand positioning have similar definitions. The scientific definition is, the larger the mass of an object, the more force that is required to change its direction. The marketing definition is, the larger the brand, the more effort that is needed to change its positioning. The second one is Heisenberg's uncertainty principle and consumer behavior. The scientific definition is, it is impossible to measure state of a particle, the dimension and position of a particle, because the act of measuring changes it. The marketing definition is, the act of observing consumers changes consumer behavior. Scientific method in a modern physical problem. The problem that was solved was scientists became a step closer to finally understanding quantum mechanics. Physicists developed a new quantum simulation protocol. One thing the researchers did was they used a scientific method to solve this problem and come up with a new protocol. The first thing the scientists did was identify that there was a problem. They did this through observations. While observing, they determined that no one was that much closer to understanding quantum mechanics. After the scientists did many observations, they then did some research on quantum mechanics. During this research, they found that some of the things they found was that physicist professor proposed to use cold atoms as a controllable quantum sensor to experimentally access key properties of interacting quantum field theories. After this, they then came up with their own hypothesis of things. Their hypothesis was about the quantum field theory and how it provides a unifying language that describes a wide variety of systems in nature across many energy scales. It also ranges from ultra-cold atoms to the most energetic particles. After that, they began their hypothesis. They tested it by showing how the generating functional can, in fact, be measured in the lab. Using strings of trapped laser-cooled ions, this was key idea because the new scheme is to map the information about the generating functional onto a collection of entangled quantum sensors encoded in an electric states of the ions. After testing their hypothesis, they came to a conclusion. The conclusion of these tests were that they continue to constitute an important step in the broader topic of quantum simulation. This aims to understand the problems in quantum many-body physics by the means of experimental systems that can be manipulated accurately to represent the quantum field theory under investigation. And here is a picture of the scientific method with some of the components that go along with it. Next, we have the classical physics principles in relation to real-life situation. Classical physics principles relate to many real-life situations. For example, everyone has heard of Newton's laws of motion at some point in their lives. In Newton's first law of motion, it states that every object will remain at rest of constant speed unless an external force is applied. This can be applied to everyday events because this is where the seatbelts in cars come into place. In an article, it talks about how the seatbelts are compulsory for car manufacturers and for us to wear. Otherwise, every time you quickly come to a stop, your face would constantly hit the windshield, dashboard, or front seat of the car. The invention of the seatbelt has greatly decreased the number of deaths on the road. One other example of this would be if you were skateboarding and a rock was in the way of your skateboard. The smart thing would be to jump off the skateboard before it hits the rock. If it hits the rock, the skateboard will stop. You will continue to fly off the skateboard in the forward motion. So, in the gist of things, the seatbelt holds you into place so you do not go through the windshield. Physics principles and various real-world examples. Connect them to your own experience. One common electromagnetic device people use on a daily basis is a doorbell. When you press a doorbell, the electric current creates a magnetic field that attracts a ringer that strikes a bell. These are special electromagnetics that function like an automatic electrical switches. One physics principle that used almost every day is a microwave. I use a microwave pretty much every day for various reasons. Although microwaves are treated separately from radio waves, they are in fact just radio signals very short in wavelengths. Not only does the microwave include only high-frequency radio and television, in fact, any type of information that can be transmitted via telephone wires or coaxial cables can also be sent via a microwave circuit. Physics principles in various real-world examples and modern technology. There are many ways that Einstein's theory of relativity are used in our everyday lives and modern technology. One way it is used is through old televisions. My mom still has an old tube TV television that she uses, but I didn't know that they were created with the help of Einstein's theory of relativity. Older TVs have a piece in them that is called a cathode ray tube. These tubes work by firing electrons at a phosphor surface using a big magnet. Each electron then equates to a lighted pixel on the screen. I find it really interesting that all of these everyday things are still used and are all in thanks to Einstein's theory of relativity. I remember a friend of mine back in middle school put a magnet on the screen of his dad's TV and it left a big black spot that would no longer show the picture. This all makes sense now because I understand the theory of relativity. Technology that uses quantum mechanics in connection to my own experience. There are many technologies that use quantum mechanics. One common technology that uses quantum mechanics is GPSs, specifically on smartphones. Smartphone navigation is enabled the Global Positioning System, a network of satellites, each broadcasting the time. The GPS receiver on the phone picks up the signal from multiple clocks and uses different arrival times and different satellites to determine the distance from each of those satellites. I am one that uses my GPS on my phone quite often if I'm going somewhere I'm unfamiliar with. Another common technology that uses quantum mechanics is through magnetic resonance imaging. The MRI machine comes from an SMA energy shift depending on how the spin of the nucleus of the atom. Those spins are quantum phenomena causing the electrons, protons, and neutrons to behave like tiny magnets. The central process of the MRI machine is called nuclear magnetic resonance. In a sophisticated arrangement of magnetic fields, it lets doctors measure the concentration of hydrogen appearing in different parts of the body. This shows things that do not show up in a traditional X-ray. One last specific example of quantum mechanics is that computers and smartphones. Talked a little bit about smartphones when we talked about GPSs, but I am one that uses my phone every day multiple times a day. If I didn't have my computer, I would not be able to get any of my schoolwork done. One interesting fact is that the entire computer industry is built on quantum mechanics. Stacking up layers of silicon doped with different elements allows us to make transistors of the nanometer scale. Millions of these packed together in a single block of material make the computer chips that power all technological gadgets. So whether it's desktop, laptops, tablets, smartphones, and even small household appliances and children's toys are all driven by computer chips. It is interesting to think all of these things that are used daily are in thanks to quantum mechanics. And there's a list of my references. Thank you.